What's that? Fortune?
Is it the same slope as yesterday?
Oh, I don't know if I don't know. Doesn't matter. Okay. So find the equation of the line that passes through the point -6, 2 and is parallel to the line y equals 1/2 x plus 7. And so you just need to realize when I say it's parallel to this line, that's just a tricky way of saying the slope is 1/2. Correct? We don't really care about the whole line, if that makes sense. Put the cap on there. All we really care about is, okay, we need a point and we need a slope, right? We have those two things, we can find the equation of the line, can't we? Okay, so all we need to do then is take this point and this slope, and we should be able to write the equation. So, Kirsten, tell me what to write.
Y minus 2 equals 1/2
Times the quantity.
times the quantity.
Yep.
X minus -6.
Awesome. Minus -6. Okay? So this is plus 6. So here we have the equation of the line that passes through the point and has the correct slope. But it's just not in the form we want, is it? Okay? We want to solve for what variable? Y. That's right. We want to solve for y. So that's what we're going to do. All we have to do, every single time, it's always the same, isn't it? We get rid of the parentheses, we use the distributive property, and then you just have this constant we need to move, right? Yeah. So 1/2 x plus 5. So if I were to graph those two, they're going to be parallel, aren't they? So here's the one, and then 1/2 x plus 5. If we graph that one as well. We good? Okay. So anytime I tell you it's parallel to this line, what am I really saying? Yeah, the slope. Here's the slope. Okay? Now, let's look at page 180. I'll be turned there right now. I'm looking at example 5 right at the top there. You guys all see the helicopter? Okay. All right. So a position of a helicopter search and rescue crew is shown in the graph. What is their position? Yeah, 14.4. That's their position. Now, that may seem weird. I mean, you guys ever see a map where your position is 14.4? No. But have you guys have you looked at maps or GPSs and seen latitude, longitude? Who's seen that before? Who's done geocaching or something like that before, right? Latitude and longitude. Don't they work just like X and Y coordinates? They work just like X, Y coordinates, okay? So they're more technical. Okay, so it tells you specifically where you are on this giant planet, but they work just like X, Y coordinates. So here we have the coordinate on the map where this helicopter is. The shortest flight path to the shoreline is one that is perpendicular to the shoreline. Perpendicular. So this is what I want to talk about next, is this idea of something being perpendicular. And here's the symbol for it, surprisingly enough. So two lines, if they're perpendicular, they intersect, but they don't just intersect any old way. How do they intersect?
90 degrees.
Yeah, 90 degrees, exactly. They intersect at a right angle. Okay? And so what I want to do is look at slopes that are actually perpendicular for a minute, okay? So let's go back to our calculator here. Negative 1/2 x plus 1. So these two lines, their slopes have something in common, right? But what's different about them? Opposite sign. Okay, now I'm going to graph both of them. And you tell me, do they look perpendicular to you?
No.
They don't. Okay, they're not perpendicular. Okay, so back to the drawing board. Let's go, instead of negative 1/2, instead of changing the sign, let's do the reciprocal. 2. Yeah, I better clear that out. 2x plus, doesn't really matter, plus 2. So these two are going to be reciprocals. Their slopes are reciprocals. Perpendicular? Okay. Now, watch this. Negative 2x plus 3. Look at the slopes of these two lines. Are they opposite signs? Mm-hmm. And are they reciprocals? Yes? Okay, so let's graph that. What do you think? Do they look perpendicular to you guys? Okay, so let's get out a piece of graph paper here. Luke, give me an equation. Y equals whatever you want.
Y equals 3/4 x plus, no, minus 3.
Okay. So negative 3, that's our y-intercept. We're going up 3, 1, 2, 3 over 4. And I'm going to do that. In fact, I'm even going to go down 1, 2, 3 and back 1, 2, 3, 4. And I'm going to get as many points as I can on the graph to make this graph as accurate as I possibly can. Okay. Now, I'm going to start in the same spot right here. Negative 3/4. So if we change the sign, 1, 2, 3 over 4. Does that look perpendicular? What do you guys think? It does look perpendicular? I don't think it does.
It's not at the,
What do you think now? Here's the point. That's 90 degrees right there.
It's not.
Definitely not, is that? Okay, so we can see that a little bit better. Okay, let's do the reciprocal. 4/3 x. So from here we're going to go up 4, 1, 2, 3, 4 over 3. Does that look perpendicular? Okay, so now we all know where I'm headed, right? What does it have to be? Negative 4 over 3x minus 3. So if I actually go down 4, 1, 2, 3, 4, over 3, what do you say? Perpendicular?
yeah.
Yeah. And we can see the protractor on there and everything. It's not sort of close or whatever. It's exactly a right angle. So it's exactly perpendicular. Okay? Now let's go back to that problem with the helicopter. So the helicopter's out there in the ocean somewhere. We know its position, 14.4. We know the shortest distance from where that helicopter is to the shoreline is a perpendicular line. You guys agree with that? I don't know if you agree with that. Here, I'll teach you a little bit about geometry, can we? So I've got this line, and I've got this point over here, point P. The shortest distance from this point to this line. Could that be the shortest distance? No? How about that right there? Could that be the shortest distance? No. What's the shortest distance? Perpendicular. They're all straight. But perpendicular, right? That's the shortest distance right there. And I can actually prove it. Okay? So look at that triangle right here. What type of triangle do we have? A right triangle. This side of the right triangle is a leg. This side of the right triangle is the hypotenuse. Which side is always longer, the hypotenuse or one of the legs of a right triangle? Yeah, the hypotenuse. The hypotenuse is always going to be longer, isn't it? Okay? And so, no matter how I draw it, any other line will be the hypotenuse of that right triangle. The perpendicular line will be a leg, so it's always the shortest distance. So that's what we have. We've got that helicopter out there. We know its position. We know a point. What else do we need in order to write the equation of this line? Come on, you all know. We got a point. What else we need? Slope. Good. We need a slope. Okay? Well, look at the shoreline. Everybody figured out the slope of that shore. And I'm going to call on somebody and you can give me the answer here in a second. It's kind of hard to see. You really got to look at it and then check yourself. All right, I think I'm pretty sure what I know what it is. Nakai, is it positive or negative?
Shore?
Yeah, the shoreline. Yeah, it's negative. Okay. All right, who thinks they know precisely what we're talking about here? What is that? Negative 2/3. Everyone check that out. Put your pencil on it if you need to. Just go down the line until you find a nice, pretty intersection. Go down 2/3, down 2/3. Check it out a few times. Is that working? Sometimes we'll think something else is right, like down 3/4 or something. But if you do it 2 or 3 times, you'll see that you get off the line. So make sure that you check it very carefully. So this is the slope of the shore. Do we want to fly along parallel to the shore until we run out of gas and die? Nakai says yes. No! No! What do we want to do? We want to fly straight to the shore, right? As quickly as we can, we want to get to the shore. So we want to be perpendicular to the shoreline. So, what does our slope have to be, guys? Oh my gosh, what does it have to be? Negative 3/2? 3/2? Opposite sign and... Okay, so we call this the opposite reciprocal. Okay, that's what it's got to be. So now we have a point and we have a slope. We can write the equation of this line, can't we? Okay, and Tyler's going to tell me the equation.
Oh, Tyler. Y minus 4 equals 3/2 times
The quantity.
the quantity of x minus 14.
Beautiful. Okay, so y subtract 4 equals 3/2 times x. That's easy enough. Now the 3/2 times 14. We know it's negative, right? So 3/2 times 14 over 1. Doesn't 2 go into 14 7 times? And 3 times 7? We can deal with that, can't we? Okay. And then last step? Add 4. Okay. So y equals 3/2 x subtract 17. So that's That's the line we want to take in order to get to the shore as quickly as possible. That makes sense? Okay? So, if two lines are parallel, what do we know about their slopes?
They're the same.
Same. If they're perpendicular, what do we know about their slopes?
They're
Opposite,
opposite and
reciprocal. Okay, so everyone needs to say that a couple times. Opposite, reciprocal. Ready? Opposite, reciprocal. Okay, so sometimes we get confused when we do this, and you guys start thinking that on the reciprocal we normally change the sign, but remember this, okay? So here's a number. Here's the opposite. Here's the reciprocal. Okay? So if I have a number like 7, what's its opposite? What is its reciprocal? 1/7. Okay? So if we're doing a perpendicular line slope, we're going to do both of those things. Normally a reciprocal, we do not change the sign. If I have an equation like this, when I multiply both sides of the equation here by this reciprocal, I want this to cancel out and give me what? Positive 1. Positive 1. So I can't change the sign. And if it's negative, its reciprocal is still negative. Okay? But on perpendicular lines, then you have to remember, you got to do both. You got to change the sign and do the reciprocal in order to get two lines that are perpendicular. Okay. Between what we did yesterday and today, I think you guys are ready to go. I want this done by the end of class when the bell rings. Chapter 4.3.